waves and the wave equation. So what I'm going to do is I'm going to first talk you through the first bit of the PowerPoint, and then I'm going to transition to working through a few of the worked examples. So in this lesson, I want you to understand what the different properties of a wave are, know the wave equation, be able to use the wave equation in calculations, and be able to remind yourself on interpreting numbers in standard form. So your first task is to read through slide 2 and work out what the meaning of amplitude, wavelength, and frequency are in your notes, and then use the wave equation and the formula triangle used for rearranging. I don't need you to submit any work for this task. This is just for you to get acquainted with this, and this shouldn't take you too long. I think this should only take you around 10 minutes or so, just to acquaint yourself with to start with. So the definitions first. Amplitude, this is how high the wave is, and this is measured from the middle to either the top of a peak or the bottom of a crest of a wave. Wavelength, this is the distance between 2 points on a wave, and it's measured in meters. So you can see here that it's either the length of one whole wave from going up and down and back up to the middle again, or going from all the way down a peak to the very bottom, all the way back up to the top of the next one, or the distance from the bottom all the way to the top until you get to the bottom again. It's the length of one wave. It doesn't matter where you measure it from, as long as the same part of the wave is where you start and where you finish, and we measure that in meters. Frequency, this is how many waves pass by every second. We measure that in hertz. Hertz is a unit which is 1 per second. So 1 hertz means 1 wave every second. So if you have a measure of 10 hertz, that would be 10 waves coming past in 1 second. So these are the 3 parts of the wave: amplitude, wavelength, and frequency. So the wave equation we use to find out how fast a wave is moving. And we need to know the frequency and the wavelength to do this. So the equation, which you'll need to remember, is wave speed, which has the abbreviation V, is frequency, F, times wavelength, and that little upside down Y is a Greek letter, lambda. And the units for wave speed are meters per second, frequency are hertz, and wavelength is meters. Sometimes on the more tricky questions you might be asked to convert units, but today we're just going to be keeping these all in either meters per second, hertz, or meters. Now the equation triangle, to rearrange this, has V at the top and then F and lambda at the bottom. And remember, if you're using one of these triangles, all you need to do is with your thumb cover up the one you're trying to find, and it will tell you what to do with the other things. So for example, if you were trying to find frequency, you would put your thumb over the F for frequency, and it would tell you that it is wave speed divided by wavelength. So in task 2, you're going to be watching this YouTube video and working through the questions to follow. So I want you to send me your completed work to my email address, and this is what we're going to be working through. So the standard form on a calculator depends if you have a Casio or a Sharp. I know some of you have other types of calculators, but there's so many different types out there. I've just focused on the main 2. If you're going to be entering the standard form number 3 times 10 to the 8, you would type the number 3, then press this times 10 to the 8 that I've circled in red here, and then put the 8, and then press equals. If it was on a Sharp, you would do pretty much the same thing, but you'd press 3, then this EXP button here, and then the number 8, and then equals, and then that will give you the correct number shown on the screen. So we've got 4 questions I'm going to ask you to work through. The first is that a water wave has a frequency of 2 hertz and a wavelength of 0.3 meters. The next is finding the wavelength of a water wave. The next one is finding the wavelength of speed of sound in air. And the last one is finding the wave speed of light. And I'm going to work through each of these in turn. In this first question, you're asked to find the wave speed when a wave has a frequency of 2 hertz and a wavelength of 0.3 meters. The way we do that is using the equation wave speed equals frequency times wavelength. And this is an equation you need to be able to remember. So using the information from the question, we've got a frequency there of 2 hertz and a wavelength of 0.3 meters. We can put the numbers into our equation and times them together. So 2 hertz times 0.3 meters. And we tap those numbers into our calculator and we get an answer of 0.6. And we have to then remember the unit for wave speed, which is meters per second. Question 2 is more complicated than question 1 because you are going to need to rearrange. So I've included the formula triangle on this slide. So again, we start off with our equation that wave speed is equal to frequency times wavelength. And this time we need to look and see the information in the question. So this time we're asked to find wavelength. So the way we do that is covering up the lambda sign, the upside down y, which I'm circling here. We can then use the triangle to show that the wave length is equal to the wave speed divided by frequency. We then go back to the question and we use the information we've got. So we're told that there is a speed of 1 meter per second and a frequency of 5 hertz. So we take that information from the question and we plug that into our equation, wave speed divided by frequency. And 1 divided by 5, when you do it on a calculator, is 0.2. And then we remember the unit is meters for wavelength. Again, in question 3, we have to use the wave equation, wave speed equals frequency times wavelength. And again, we're asked to rearrange. So Dave is asked to find the wavelength of the sound. We've got the frequency and the speed. So what we're going to do is we are going to cover up the wavelength, again, at the bottom right-hand corner of the triangle, and see that wave length is equal to wave speed divided by frequency. We can then take the numbers from the question. So in this case, we've got the speed is 330 and a frequency of 660. And we can plug these numbers into our equation. So here is our wave speed, 330, and our frequency, 660. And we divide those through, and on a calculator, we get an answer of 0.5, remembering that the unit for this is the meter. Question 4 is by far the hardest question because we are using standard form in this question. Now, standard form is tricky because it's not something you use on an everyday basis, and I've included on the PowerPoint slide how to use standard form in a calculator. So in this question, we're going to start off again with wave speed equals frequency times wavelength, and again we're asked to find the wave speed. So we're going to just put our numbers in: 6 times 10 to the minus 7 times 5 times 10 to the 14. Now, at this point, we will need to use our scientific calculator. And in this instance, what I've done is I've switched over to using the calculator app on my iPad to type this in. And you can see here how I would do this. But depending on how you would do this would depend on the type of calculator you've got. I've included instructions for how you would do this on a Casio and a Sharp on our PowerPoint slide. So when we times these two numbers together on our calculator, we get an answer back in standard form, and our answer here is 300 million meters per second, or 3 times 10 to the 8 meters per second, depending on whether you use standard form or ordinary form. So, the worksheet questions. I'm going to give you a walkthrough to parts A, E, and I on the first question. So the first thing you need to do here is use the equation. Wave speed is frequency times wavelength. And in the first question, it's nice and simple. All you have to do is plug the numbers in. So we're going to type in 20 times 2.5 because the frequency is 20 hertz for question 1A and the wavelength is 2.5. So as we type those things in, we can pop them straight into our calculator, 20 times 2.5, and the answer will be 50. And we then have to put our unit, which is meters per second. In question 1E, it's much the same, but this time we need to rearrange. So we need to look back at that formula triangle we've used before. And in this case, we need to rearrange. So we start off with our usual formula. Wave speed is frequency times wavelength. But this time we need to rearrange to find frequency. And the way we're going to do that is we're going to do frequency is wave speed divided by wavelength. And you can see me writing this out here. Once we've got our formula correctly rearranged, we can then just take the information straight from the table and put the numbers in. So in this case, our wave speed is 0.5 meters per second and the wavelength is 5 meters. So all we're going to do is 0.5 divided by 5 to give us the answer 0.1. And then the unit, which in the case of frequency is hertz, capital H, little z. In the very final question that I'm going to walk you through, question 1 part I, we have to find the wavelength. So in this question, the way we find the wavelength is again, starting off with the equation, wave speed is frequency times wavelength. And I keep doing that and keep going over it because it's so important that we remember that equation. Again, we then need to use our formula triangle to rearrange to find wavelength. And the way we would do that is we would write that wavelength is wave speed divided by frequency. We can then go to our table and find the information in the table. And what you can see there is that the information is in standard form. So again, if you're not sure on how to enter numbers into standard form on your calculator, have a look at my work through example on the PowerPoint. So 6 times 10 to the minus 5 divided by 0.098. And when we put this together, we can tap it into our calculator, just working it through here as I go. 6 times 10 to the minus 5, so I'm typing 6, pressing the times 10 to the x because I've got a Casio calculator, and then typing minus 5, and then dividing that by 0.098, and the answer is 0.000612 meters per second, or if you put that into standard form, that is going to be 6.12 times 10 to the minus 4 meters per second. The way you can switch between standard form and ordinary form on a Casio calculator is through pressing the SD button on the Casio's calculator row. It's just above the delete key. On a Sharp calculator, there is a button labelled change. That's just above the brackets key. And again, that will change between the two types of form.